Okay, now let's do question 2, Pokemon. Identify the errors that occur when compiling and running the code to the right. I actually put it, oh well, it's actually below. It's this code is what we're going to run. This is the code that was provided to you. Assume that if a line errors, it will not affect the execution of later code. Okay? So we are starting off by saying, okay, so I'm going to kind of just keep track of the static and dynamic types of P and A, okay? So this will be P, and this will be A. This will be the static type, and this will be the dynamic type. Okay, so what is the static type of P? Well, the static type of P, oops, that's not readable, is going to be Pikachu. And what is the dynamic type of P? Well, it is also Pikachu. Now, how about A? Static type of A is Pokemon. Remember, the static type is the thing to the left of the equal sign, and the dynamic type is the thing to the right of the equal sign. So the dynamic type of P is going to be Pikachu. Sorry, of A. Okay? So now let's look at this line right here. P will be equal to A. So what I'm trying to do here is I'm trying to assign something with static type Pikachu to something with static type Pokemon. Okay, now remember from last week, we talked about the relationship between the static and dynamic type. The dynamic type needs to have an is a relationship with the static type. Oh no, am I recording this? I hope so. So now we can ask ourselves, is a Pokemon is a Pikachu? Well, this is similar to our dog poodle example, right? Or dog beagle example, right? Some dogs are poodles, some Pokemons are Pikachus, but not all of them are, right? So this is just not something that we can say for sure, and this is going to be an issue, and we are going to get a compile time error. We could solve this by doing a cast. We could cast the Pokemon to be a Pikachu, and then we wouldn't have a compiler error, a compile time error. Now, what happens when we do a.eat? Well, A has a static type of Pokemon, so I'm going to look in the Pokemon class, and I'm going to jot down a method with method signature eat. Now, runtime is going to come around, and I'm going to look into the subclass of the dynamic type of A, which is Pikachu, and I'm going to look for a method with method signature eat. And I find one. It's going to be right here. So I am just going to print nom Pika nom. It's kind of cute. Okay, so there were no issues with that. Now I'm going to say A is equal to new Squirtle. So I'm changing the dynamic type. So now I am interested in calling A.attack. So A has a static type of Pokemon, so I'm going to look in the Pokemon class for a method with method signature attack, and lo and behold, I do not find one. Okay, be very, very careful when looking at these method signatures. They have to match exactly. They have to be exactly the same. And we can see that in the Pokemon class, the attack method is taking in a Pokemon, but that's not what we have down here, right? We have something that doesn't take in anything. Now that is something that we find in the Squirtle subclass, but at compile time, we are not concerned about dynamic types, right? We're thinking about static types. So this is going to end up being a compile time error because we can't find a method with that method signature in the static type class, okay? So now we are going to cast A into being a Squirtle, right? So this is a cast right here. And we're casting A into a Squirtle and then calling A.attack. So at runtime, what's going to change about this? Well, at runtime, we're kind of going to temporarily, at compile time, what's going to change about this? At compile time, we're kind of just going to temporarily set aside this static type of Pokemon, and we are going to do our checks as if A had a static type of Squirtle. So that means that we're going to look in the Squirtle class for a method with method signature attack, and we will find one this time. And then when runtime comes around, we're once again going to look into the dynamic type subclass, which is again Squirtle, and we'll find this same exact attack method, and we will be able to say water gun. So that worked out, okay, thanks to the casting that was performed here. Now we're going to say Pokemon Z is equal to a new Pikachu. I'm going to get rid of this. Okay. And now we're going to say Squirtle S is equal to Squirtle Z. Okay. Is equal to something that's Z being cast to a Squirtle. Okay. So what's going to happen here is when we do a cast, we're basically telling Java that during compile time, Java just needs to trust us, okay, in terms of the type checking. We don't actually want to look, we don't want Java to actually look into the details of Z during compile time, okay? We are telling it, Java, that it just needs to trust us that Z is going to end up being a Squirtle, okay? So for purposes of compile time, there's no issues with the relationships between the static type and dynamic type of S, right? They're exactly the same. There's no violations or anything like that. So compile time will be fine. But during runtime, we are going to get a runtime error because something with a dynamic type of Pikachu cannot be cast to a Squirtle. Okay, so this is going to give us a runtime error. So down the road, you can kind of think of it like in that sense. The cast, it solved our problem right now, but down the road, we're going to run into issues because this is not a legal cast. Okay. And I think that is all of the worksheet problems. Okay, so thank you for watching.